Hello students. In this class, I am going to teach you how the Hamilton equation of motion for a simple pendulum to be calculated or to be derived. So, we already saw the Lagrangian equation for a simple pendulum. Now, we will solve the equation of motion for a simple pendulum using Hamilton's equation. We already know about the simple pendulum. There will be a fixed point, that is there is a fixed point. Then from that fixed point, a bob will be at the end. Okay. This will be a bob. Will be at the end. When it oscillates, it reaches a position like this. It reaches a position. Then it makes the angle theta with the position OA, fixed position OA. Then it reaches the point C. Let us consider this. Then what will be the height difference? So this is the height difference H. Here potential energy will be 0. Then this is the position of C. So you make it as B here. The total length of this pendulum is L. So if this is L, then this is also L. So this is the simple pendulum, we know. Now how to solve or how to derive the equation of motion for a simple pendulum using Hamilton's equation. For this, you follow some steps. You don't want to write this in the examinations. You just know the things. How to solve this. These are the steps to solve the simple pendulum equation. First, you should find kinetic energy. Then find what is the value of potential energy. Then find Lagrangian equation. Then find Hamilton's equation. Then use canonical transformation equations. So these are the steps to solve this problem. First you should find out the kinetic energy T. Then you want to find out the potential energy V. When T and V we know, then you will find out the value of Lagrangian value L is equal to T minus V. From that you will find out the value of H also. By using this L and H in the equations, you substitute the canonical transformation equations that we already saw in the earlier video. What is the value of Pi and what is the value of Qi and what is the value of dou L by dou T, etc. It is the canonical transformation equations. So if you have any doubt, you see my earlier videos and you will understand what is canonical transformation equations, and that values should be applied. Then we finally find out, then we will finally get the simple pendulum equation. Okay, right. So what are the steps? Find out kinetic energy first, then find out the potential energy, then Lagrangian equation, then Hamiltonian equation, and use canonical transformation equation. We will get the equation of motion for a simple pendulum. Okay, now we will see one by one. Okay, so now we know that kinetic energy, that is equal to half m V square. Okay, we know the formula. Similarly, potential energy, we know the formula mgh. Okay, now from this figure it is clear that angle theta, that is equal to arc by radius. So we know already. What is arc? Arc value is s here. What is arc means? You make this is arc. Okay, so this is s. Now s by radius, what is the radius here? That is the length. L is the length. So s is equal to L theta. Understand? S is equal to L theta. Now differentiate this s. Now differentiate this s with respect to t, because when the bob is oscillating with respect to time, then you differentiate with respect to t. So ds by dt, that is equal to L into d theta by dt. Okay, or ds by dt is nothing but v, velocity v, where s is the distance, then distance by time is nothing but velocity. So v is equal to L into d theta by dt is represented as theta dot. So we know the value of v. So what will be the kinetic energy then? Ke, kinetic energy T, that should be is equal to half m v square. Okay, instead of v you substitute this value, therefore T, that should be is equal to half into m into L square theta dot square. Understand? Now you make it this equation number 2 and this equation number 1. So this is equation number 3. Half m square, sorry, half m L square theta dot square. Okay, so what will be the potential energy now? Potential energy V, that is equal to m into g into h. Here m into g into h is the total length. H is the total length. Therefore h will be m into g into ab. Okay, m into h into ab. So this ab is nothing but OA minus OB. Therefore m g OA minus OB. Okay, that is the V. Now to find out this value OA OB, take the triangle OBC. You see this diagram OBC, you see this diagram here. Take the triangle OBC. Here find out cos theta. Cos theta is equal to OB by OC, nothing but OB by OC is nothing but the value of L. Therefore OB, that is equal to L cos theta. Okay, OB is equal to L cos theta. Substitute this value here. Therefore V equal to m into g into OA is nothing but full length, so it is L minus L cos theta. Okay, V is equal to m g L into L cos theta, or you take it L outside, so m g L 1 minus cos theta. So this is the value of V. So we calculated first kinetic energy, then I calculated potential energy. Now I want to calculate what? The value of L, that is Lagrangian L. Okay, now you see. Wait a minute, the video is not correct. Then only you will see the things. Okay. Right. So V is equal to mgl 1 minus cos theta. Right. Now we want to calculate the Lagrangian L of the system. We know that L is equal to T minus V. L is equal to T minus V. Therefore, L, that is equal to, what is the T value? Half into m into L square into theta dot square minus what will be V? mgl into 1 minus cos theta. Okay, we make it equation number 5. Make it equation number 5. Now we know that Pi, that is equal to dou L by dou Qi dot. Okay, these equations we already saw. Pi is equal to dou L by dou Qi dot, where Pi is the generalized momentum coordinate, Qi dot is the velocity coordinate. Here, in the case of simple pendulum, Pi is nothing but P theta, because here the generalized coordinate is theta. With respect to theta only everything happens. Therefore, here the generalized coordinate, instead of I will use theta here. Therefore, Pi is equal to P theta. Similarly, here the momentum term, here the velocity term Qi dot is nothing but theta dot. Okay. So, in the case of simple pendulum, Pi equal to P theta, Qi dot equal to theta dot. Therefore, what will happen this equation? Instead of Pi, you make it P theta, that is equal to dou L by dou theta dot. Okay, dou L by dou theta dot. You just make it equation number 6. P theta equal to dou L by dou theta dot. Now differentiate the equation 5. Now differentiate the equation 5 with respect to theta dot. Differentiate the equation 5 with respect to theta dot. Okay. So what will happen? Dou L by dou theta dot, that is equal to half into ml square. Theta dot square is nothing but 2 into theta dot. There is no theta term, therefore the second term will becomes a 0. Therefore this half 2 will be cancelled. So remaining term is dou L by dou theta dot equal to ml square theta dot. Okay, dou L by dou theta dot equal to ml square by ml square theta dot. Now this equation 6 becomes, you see, dou L by dou theta dot. Instead of that you substitute in equation 6. What will becomes P theta dot, P theta, that is equal to ml square theta dot, or theta dot, that is equal to P theta by ml square. Now again you differentiate this, what will happen? Theta double dot, that is equal to P theta dot divided by ml square. To make it this equation number 7. Okay, right. So theta double dot, that is equal to P theta dot by ml square. This is equation number 7. So we calculated kinetic energy, we calculated potential energy, We calculated the Lagrangian equation, that is equation number 5. We already calculated. From that we find out the value of p theta and the value of theta double dot and the value of theta dot. Now we want to calculate the value of Hamiltonian H. Now Hamiltonian H of the system, Hamiltonian H of the system is, we know that the Hamiltonian also we know. What is the value of Hamiltonian? H is equal to Pi Qi dot minus L. H is equal to Pi Qi dot minus L. But here we know in simple pendulum Pi is equal to P theta, Qi dot equal to theta dot. Okay, we already know. Therefore, this equation becomes H is equal to P theta, theta dot minus L. Okay, you understand this? Instead of Pi you make it P theta, Qi dot you make it theta dot, then this minus L. Now substitute all the values. H is equal to, I know P theta value. What is the P theta value? P theta is nothing but ml square theta dot. Ml square theta dot. Therefore ml square theta dot into theta dot minus, instead of L you substitute the value from equation number 5. It is the value of L. What is that value? Of ml square theta dot square minus mgl into 1 minus cos theta. Now you simplify it, what will happen? ml square, this theta dot square minus of ml square theta dot square minus here minus of minus plus mgl 1 minus cos theta. Okay, now this is ml square theta dot square minus half ml square theta dot square, so the remaining will be h, that is equal to half ml square theta dot square plus mgl into 1 minus cos theta. Okay, now you see this represents kinetic energy and this represents potential energy. We know H is equal to what? We already saw in Hamilton function itself. H is equal to T plus V. It came na? H is equal to T plus V. That is, T plus V is nothing but the total energy. T plus V is nothing but total energy. Therefore, H is equal to the total energy which should be conserved. So, this simple pendulum is a conserved one. The energy should be conserved. Okay, so the system will be conserved system. Now, that is, instead of this theta dot square, you substitute the value of theta dot here. Theta dot equal to P theta by ml square. So you substitute here that value. Similarly, theta double dot value, then we will get, let's see, we will see the derivation. So H now becomes, H is equal to half ml square. So the theta dot, you substitute P theta divided by ml square, the whole square, plus mgl 1 minus cos theta, where theta dot equal to what? P theta divided by ml square. Now H is equal to half ml square p theta square divided by m square L power 4 plus mgl 1 minus cos theta. Now half this m will cancel, this L square, this L power 4, therefore here one L square, therefore half p theta square p theta dot, you just make it p theta, no p theta dot, only p theta. So p theta dot square p theta dot square divided by ml square plus mgl 1 minus cos theta, to make it number 9. But we know that now we calculated H also. So calculated the kinetic energy, calculated the potential energy, then Lagrangian equation, that is represents the equation number 5. Now I calculated Hamiltonian equation H. It is represented by the equation number 9. So now I am using canonical transformation. We know by canonical transformation, equation of motion is pi dot, that is equal to minus dou h by dou qi, and qi dot, that is equal to dou h by dou pi. These equations I already solved in canonical transformation equation video. You just verify it. The same value here we have taken. Pi dot is equal to minus dou h by dou qi, and qi dot, that is equal to dou h by dou pi. But here in simple pendulum, p theta dot, that is equal to minus dou h by dou theta, because here the generalized coordinates, here I is theta and here qi is theta, therefore qi is the theta, therefore substitute this value p theta dot, that is equal to minus dou h by dou theta. Therefore we already know these things, we derived, that is theta double dot, that is equal to p theta dot divided by ml square. Okay, so from that we know p theta dot, that is equal to ml square theta double dot. Okay, therefore now substitute this value here, p theta dot, instead of p theta dot you substitute ml square theta double dot, that is equal to minus dou h by dou theta. You make it equation number 10. We know equation number 9. What is that? H is equal to half p theta dot square ml square plus mgl 1 minus cos theta. Now differentiate equation 9 with respect to theta. So when you are comparing the equation, when you are seeing the equation number 9, the first term there is no theta term, therefore that term becomes 0. So the remaining term only is h is equal to mgl minus cos theta is differentiated as sin theta. Okay, therefore mgl sin theta, that is dou h by dou theta, that is equal to mgl sin theta. So now equation 10 becomes, you see equation 10 ml square theta double dot, that is equal to minus dou h by dou theta is mgl sin theta. Okay, then it is very simple. Theta dot double dot, that is equal to minus mgl sin theta divided by ml square, or m cancel, this l cancel, therefore theta double dot, that is equal to minus g by l sin theta, or theta double dot, that is equal to, theta double dot plus this sign comes here, theta double dot plus g by l sin theta equal to 0. Theta double dot plus g by l sin theta equal to 0. Now, when the vibration is small, that is when theta is small, then sin theta is equal to theta. Sin theta becomes theta. Therefore, theta double dot plus g by l into theta equal to 0, which is nothing but the equation of motion for a simple pendulum. Equation of motion for a simple pendulum. Theta double dot plus g by l theta, that is equal to 0. This is called as Hamilton's canonical transformation equation of motion for a simple pendulum. Canonical transformation equation of motion for a simple pendulum. If there are oscillations takes place, we may find out the frequency and what will be the time. We will also calculate the frequency and the time from this equation. How? So, theta double dot, that is plus g by l into theta equal to 0. Now I want to calculate the frequency. How the frequency will be calculated? Theta double dot plus omega square theta equal to 0, where omega square equal to g by l. Omega square is equal to g by l, or omega is equal to root of g by l, where this omega is called angular frequency. Angular frequency omega. Therefore, omega, we already know omega equal to 2 pi nu. We know omega is equal to 2 pi nu. Therefore, 2 pi nu, that is equal to root of g by l, or nu is equal to 1 by 2 pi root of g by l. This is the frequency of simple pendulum. We already know. Similarly, time period. Time t, that is equal to, it is the reciprocal of, that is, it is 1 by nu, reciprocal of nu, that is 1 by nu, that is 2 pi root of l by g. So this is time. T is equal to 2 pi root of l by g. So this is time period of a simple pendulum, and this is the frequency of the simple pendulum. Okay, so this is the method to derive the equation, canonical transformation equation for a simple pendulum using Hamilton's equations. Okay, so for this, what are the steps? First, you should calculate the kinetic energy, then potential energy, then Lagrangian equation, then Hamiltonian equation, then canonical transformation. We are then using the canonical transformation equation of Hamilton, we will find out the canonical transformation equation of motion for a simple pendulum. Afterwards, we are finding the value of frequency and the value of time t. Okay, if you have any doubt, you just ask me. We will meet you in the next class. Okay, thank you.